Welcome again. Today we will discuss the timestamp ordering and validation protocol for concurrency control. Now, what is timestamp? So timestamp is a unique identifier which is associated with every transaction, or we can say that a timestamp is the entry time of that particular transaction into the system. The timestamp is a very important concept. If you have a greater timestamp or larger value of that particular timestamp, then you are older one in compared to the transaction who has a larger timestamp value. This concept you can understand with the help of example, where we can consider the timestamp as a birth of year. Suppose my birth of year is 1977 and your birth of year is 1999. So who is older in compared to us? Because my birth year is 1977 and your birth year is 1999. So I am older in compared to you. But the timestamp value of my timestamp is 1977, which is smaller to your timestamp, that is 1999. So I have smaller timestamp value, but I am older. The same concept is applicable to the timestamp of transactions. If a transaction has a smaller timestamp value, it means it is older, while a transaction who has larger timestamp value is a younger one. So that is the concept of timestamp, and it is important one. Now we will move forward and look for what is the basic timestamp algorithm timestamp ordering algorithm, sorry. So here, whenever a transaction T want to use, then for every data item we associate two timestamps with every data item. The first is read timestamp and second is the write timestamp of X. So what is read timestamp of X? In read timestamp of X, it stores the timestamp value of the transaction who is the youngest and successfully read that particular data item. Similarly, the write timestamp of X stores the value of the timestamp of the youngest transaction who successfully written that particular data item X. So both timestamp always stores the youngest value, the value of the timestamp of the youngest transaction who has successfully completed respective operations on this particular data item. Now, basic timestamp ordering algorithm. So whenever a transaction T tries to read or write that particular data item, then the basic timestamp algorithm checks two cases. So the first case, where transaction T issues a write item X operation. As we know that write operation is in conflict with read as well as write, so we have to check the both read timestamp as well as the write timestamp to make it serializable, to ensure that the serializability will not disturb. So what it is checked, the algorithm what checks, it checks that if read timestamp of X is greater than ts of T. What does it mean? It means that the transaction who successfully read that particular data item X is younger than the transaction who is requesting the value. Means T transaction is older in compared to that transaction who has successfully read that particular data item X. Similarly, or the same condition, write underscore ts of X is greater than ts of T. It also indicates a younger transaction have already written that value in compared to T transaction. Then if this condition is satisfied or true, then we have to abort the transaction T and roll back T. In second case, if this condition is not satisfied, it means the transaction T is a younger transaction, so we will allow or we will execute the write item X of T and set write ts of X to ts of T. In the second case, transaction T issues a read item X operation. If transaction T issues a read item X operation, then again, because it is a read item operation, then we have to check only the write timestamp, because read with read is not in conflict. So the algo will check that write ts of x is greater than ts of t or not. If it is so, then we have to abort. What it indicates? It indicates that a transaction t which is younger to transaction t, a transaction t dash which is younger to transaction t is already written that value. In such scenario, we have to abort this operation and roll back t. But if this condition is not true, it means if write ts of x is less than or equal to ts of t, then execute read item x of t and set the read ts of x to the larger of ts of t and the current read ts of x, because we have only checked that write timestamp. So there is a possibility that the read timestamp can be larger. So we have to set the read ts of x to larger of both. If t is younger, then we have to make it to set it to ts of t, but if it is not, then we have to make it read ts of x. Then we move forward. Sorry for the delay. The basic TO algorithm may cause the cascading rollback. Why? Because whenever we are using the basic TO algorithm, so it is reading and writing the values on based on the timestamp, but those transactions are committed or aborted, it is not checked in the basic timestamp algorithm, so it will suffer by the cascading rollback. So how we can change that, or how we can arrest this problem? So the variation to basic TO algorithm is known as strict timestamp ordering, which can arrest the problem of cascading rollback. So what are those? How we are changing those? So we have made slight change in the basic TO algorithm, and it will become the strict timestamp ordering. So what is the first case? The transaction T issues a write item X operation. If so, then it checks that TS of T is greater than read TS of X. Then if this condition satisfy, means the transaction T is younger, then when we permit, in basic algorithm we permit the write operation, here we will not permit immediately. What we will do, the algo will state that delay t until the transaction t dash that wrote or read x has terminated, means the transaction who read or write that particular value is not terminated. So we will write only the committed values. Then the second case, that is read item x operation, it again states that if ts of t is greater than write ts of x. Simply, if the transaction t is younger transaction, then we have to delay t until the transaction t dash that wrote or read x terminated, means committed or aborted. By this variation, by this slight modification, we are ensuring that the transaction will read or write only the committed value, and if we are doing so, then it will ensure that no cascading rollback will get effect. Now the Thomas Wright rule, this is again a very important concept by which we can avoid some writings in the database without affecting the consistency of the database, and that is known as Thomas Wright rule. If you remember that, because it is a write rule, so it is applicable only write item x operation. How? If you remember the write operation, then whenever in basic TO algorithm, whenever we are writing, we are checking two conditions. One is read ts of x or greater than ts of t, or write ts of x is greater than ts of t. Here in Thomas Wright rule, we are bifurcating both, we are making them independent, and if this is there, then the similar we will follow the similar rule of the basic TO algorithm, then abort and roll back t and reject the operation. But if write ts of x, right, ts of x is greater than ts of t, means a younger transaction has written the value of x, then just ignore the write operation and continue execution, means there is no need to abort the operation and roll back t. And that is the advantage of Thomas Wright rule. This is because the most recent write counts in case of two consecutive write. So most recent means a younger transaction already written that value, so no need to write it again. And if both conditions are above do not occur, then simply execute write item x of t and set write ts of x to ts of t. It is again similar to the basic T algorithm. This is again rule number 1 is also similar to basic T algorithm, that is known as the Thomas Wright rule. Now we will move forward for the second concurrency control protocol, that is validation concurrency control protocol or optimistic concurrency protocol. This validation protocol has three phases. First phase is known as read phase, second phase is known as validation phase, and third phase is known as write phase. And it checks only in the validation phase, remaining it does not push any protocol or any condition for the transaction execution. So whenever the transaction comes in the validation phase, then only it checks for the serializability. So we will start that what is read phase. First, read phase. In read phase we always read only the committed values, and we will not update. The transaction will do the changes, and write operation will not be affected by the affected in the database, means we are not going to write into the database. The all changes or write operation will remain in the cache. So we will read committed value, and no write is going to be written in the database, so it will remain in the cache. That is known as read operation or reading phase. When transaction completes its operation, means all writes are there in the cache without affecting the actual database, then that transaction comes into the validation phase. In validation phase, that protocol checks all operations for the serializability, and if that test pass, the transaction passes that particular test, then only it moves to the write phase. If it does not passes uh, that test, then the transaction is aborted and roll back. But if it passes that transaction, that test, then it moves into the write phase, where all write operations get affected into the database or onto the disk, so by which we are able to maintain the concurrency or the serializability of the schedules. So that is known as validation concurrency control scheme. Thank you for listening patiently.